Today we're gonna make plants, as you saw from the intro for this little dancing concerto, whatever. This is the plant that we're gonna make. As you see, it's currently quite small. If we increase the slider here, it's gonna grow just like a normal plant. I mean, I could have this as a pot plant. This wouldn't be like too horrible in a corner of your room. So let's make this plant right. For the first thing, what we need is a new scene. And then we have a lot of steps that we have to follow. The first thing that we need is the plant stem. So to create that, what we need is just add geometry nodes, and then we can either use a mesh line, and this looks perfectly like the starting point of a plant, but the problem is it doesn't have this node called curve parameter. And this node gives us, in case of a curve, a gradient from the starting point to the end point, so 0 to 1, right? And we can use this to make the plant grow, to make the leaves be smaller down there, to make this shrink and get fat and whatever. So this is very useful. And in case of mesh lines, we don't have this. In case of curves, we do have this. So let's add a curve called quadratic Bezier, which is just a fancy word for a curve. Doesn't look too much like a plant, so let's make the thing look like we had before, like going up, right? So for that, let's zero out all those points here, and let's make sure the start is in the 0, 0, 0 in the beginning here, and the end is gonna be just 1 meter up, so something like that. The middle thing here is like that, 0.5 on the z-axis. We have made the stem. Now the next thing is to make it thick. Actually, I don't like this layout. This is I like this one more. So let's use the geometry node editor on this side, and let's put it here. Now we need to make it thick, and for that what we need is a curve to mesh node, which is kind of the only way to make something thick. Make a curve thick, because curves, as you know, are very thin things. They don't have actually any like geometry that can be rendered out. So we need to make this a mesh. Right now this is a mesh of just 16, as you see here, 16 vertices going up with the distance of 1 divided by 16, right? Because this is the endpoint. But we are going to use a circle to wrap around this curve, and we cannot use the mesh circle because this is a curve. So let's use a curve circle. Let's put it here, and let's connect this to the profile curve. Now this looks like a barrel of actually nothing, because it doesn't have a bottom. So let's make this a bit less thick. Let's say 2 centimeters, and the resolution can be something smaller, for example 12. The next thing is to make it wiggly, because it is thick and it is a stem. Now we need a wiggly and thick stem, and for that we need a noise texture, because a noise texture allows us to create like random values but in a specific region. So for example, if we just use a random value, this would just result in a stem that is completely random in every direction, because all the points are getting a completely random location. But the noise texture is something that is more smooth, depending on the scale, so that we can get a plant stem. So now we have here this noise texture, and I also tidied up this thing a little bit because this looked a bit ugly. And to use this noise texture as a new position for our stem, we need to use a node called set position. Now, set position sets the position of a point based on an input, or offsets them based on an input. For example, if we offset them 1 meter on the x-axis, they should move right here, like that. Let's see if this is the case. It is the case. So we have understood everything correctly. Let's put this back here. Let's delete this wiggly line. Let's use the noise texture as the offset. Now something like that happens. Why does this happen? The reason is that, here we have quite a lot of points, 12 by 16. So 16 in this direction and 12 like that, because it is a circle with a resolution of 12 mapped on 16 vertices. So we have this amount of points, and every point is gonna get displaced by a random amount, which means, for example, if I make the scale smaller, right, it does look like a plant stem and all, but it's not like a circle. It's more like a vacuum cleaner's like pipe that you have stepped onto, drinking straw that you have chewed a little bit too much. And to fix that, what we need is to displace the curve before it reaches this circle curve to mesh thing here. So let's put this before, and let's add the color to the offset. Now it's looking nice, but the problem is it has shifted up And the reason behind that is the fact that noise texture, as you know, looks like that. So you have dark values and you have white values. Dark is 0, white is 1. So you have everything between 0 and 1, and on average this is 0.5. So this is gonna be displaced by 0.5 on all the axes. So let's do so that you use a vector math node and subtract something from its position. Subtracting something in this case is basically just moving these on axes. So the first thing here is x, then is y, then it's z. So when we move this like that, so we subtract this amount, it's gonna move back here. So if you subtract 0.5, it's gonna be on the y-axis here correctly. And now if we subtract from here as well 0.5, it's gonna move pretty much to the center. Now we also have to move this down on the z-axis like that. Now it's in the center. Problem being that the bottom part of the stem isn't at all fixed. So if you change this to 4-dimensional noise, which sounds crazy, right? So just have to use the V dimension here and it wiggles like crazy. Now the problem is that the bottom part here isn't attached here. So what we need to do is to make sure that whatever we are doing with the displacement, it's always going to be multiplied with 0 down here. And now this is the case where we can use our lovely curve parameter. Now the curve parameter, as I already told you, gives us range from 0 to 1 on a curve, starting from the start, ending in the end. So we can basically do so that we are going to multiply using a vector math our displacement with this thing here. Everything works as it should. It's just a quick look onto the notes in case you missed something, you want to recap on something. This looks like that. Now we need to make it thin at the top, which is the fourth thing in our list. We can make this thinner or thicker by using the curve circle here. Like that, it's very thick. Well, you might think, okay, let's use just the curve parameter, right? And let's plug this curve parameter into the radius. It should work. It doesn't work because it's red. And why is it red? Well, the reason is this input here has a circle here, right? A circle means a single value. Just, I mean, you cannot input any attributes here, anything that is different for this whole stem, right? For example, in this case here, the position, the offset here, which is different for the stem in each location, it has a little rhomboid, a little cube that has been rotated, maybe the default one, but this is actually indicating that this is an input where you can input some attributes, something that is different for each point. I mean, this one isn't, of course, because this is just a normal curve circle. I mean, this is just one object. How can you make this different in each point? So to do that, what we need is a node called setCurveRadius. Like that. Now nothing is changing, but we can here very easily make this thinner or thicker. And here, as you see, we have a little square, which means we can input attributes here. So let's use the curve parameter. I'm gonna put it here. Now we have 0 down here, which is correct because the curve parameter outputs 0 down here, and 1 up here. We just have to invert this somehow. So do we have an invert node? We don't have this, but we are very smart, so we can figure out how to make our own invert node. So for that we can use a map range. Actually, this doesn't mean the range of a map. This means let's map the range, right? I initially thought, like when I started using Blender, that this was like the range of a map or something like that. So this is used in a way that you take the original range, which is in the curve parameter case 0 to 1, which is already correct here, from minimum 0 to maximum 1. And now we're going to map this so that down here we have the new minimum of 1, and up there we have a new maximum of 0. Now we have completed 4 steps and we have not too many to go. Let's deal with the growing animation. Pretty exciting, right? Now for that we need a node which can make curves shorter. So for that we can use a trim curve. This video is sponsored by Mansk. Okay, let's put it here for example, and let's see what happens when we drag. So for example, we can trim from the start or we can trim from the end. But as you see, this doesn't look too great, right? So let's try, for example, after this thing here. And now you see, because we have already set the curve radius, it is working, but it is cutting the plant into it's a hole here, right? To get rid of that, what we need is to move the trim curve before that. So now the curve parameter is calculated taking into account the trim curve appropriate for our plant. And this works very nicely. Just a little recap on nodes. Now I have to model the leaf, but I'm too lazy to model this. So I already modeled this beforehand. and I'm just gonna append this into the scene from the intro file, which is gonna be on Patreon, by the way, and the leaf is gonna be for free in the description because this is so easy to do. Why should you ever bother doing this, right? This has a texture already. This looks like that. I downloaded the texture from Ambient CG, so you can make this leaf on your own, but just make sure it is having the same position as here and apply the rotation. So usually if you want to add something in geometry nodes, we need points. We can just use an instance on points, put it here, and then add a leaf. The leaf is here. It's called still leht, which means leaf in Estonian. Let's learn Estonian. Leht is a leaf. Okay, so I have this leaf here, and I'm gonna plug the geometry into the instance. And now you see we have a massive amount of nature. Too many, right? We don't want as many leaves. Let's do so that we actually plug this before we make this mesh, right? So we do this like that. Now we cannot see these leaves, of course, because the node tree has separated here. So we need to use a join geometry node to put this back together. The family is together again. Now the problem is that they have all a distance between them, like a fixed distance. So this doesn't look very natural. Okay, they are also rotated in a very wrong way, but this, I mean, let's deal with the distance first. So I want to control the amount of leaves I have. So for that, I'm going to use a resample curve node, which is going to resample into a number of pieces I wanted to resample to. So if I put 1 here, I'm only going to have 1 leaf. If I put 2, 3, 4, 5, I'm going to put here 24. And of course, I don't want to have as much of leaves here. I just want to have like a choice between those leaves, and then I'm gonna randomly choose some of those leaves. How do I do this? Let's leave this question unanswered right now, and let's first turn them into their nice rotation. Very hard to see what we're doing if they are so random like that. The rotation of the object, let's plug this into the rotation. Doesn't work, right? Because we have to align this to something. So let's use an align Euler to vector, put it like that, and now this has done something. Let's try out these things there. Okay, Y seems to work. Yeah, it works, but not very well, because you know, they're all exactly like that, like a stack of like money, for example. This doesn't look very good because, for example, in this case, they should be pointing a bit more downwards to be like, is the word perpendicular to the stem? For that, we have to use a function of the curve called tangent. Now, tangent doesn't probably mean anything in English except for this thing, but in Estonian, the curve tangent is called puutuja, which means the toucher. So when you have a curve, then you have also the tangent or the toucher in Estonian, because it touches the curve in only one location. So this is, I think, a bit more logical way of thinking about the tangent. Now we can use the tangent as the vector to align those things too. And now this looks a bit better. This follows the rotation of the curve and it looks a lot better, I think. The problem is that there are too many leaves. So let's select just a random amount of those. As you see here, we have a selection. What does this mean? This means a Boolean that is either true or false. Either we have leaves or we don't have them, right? If I use just a Boolean here and I'm gonna plug the Boolean into the selection, we have leaves, we don't have them. We don't have them. So what I need is a random value, or a random Boolean value for each of those 24 leaves. And for that, we just need a random value, of course. I mean, this is an easy tutorial. Why should we overcomplicate this? We have a float here. We have integer vector Boolean, which means either true or false. So let's plug this into the selection. We have a selection. We also have here the probability and the seed. Probability means 0, like don't give me anything, and 1 give me all what you got, right? I don't want to have all what he has. So I'm gonna do something like that. This seems for about okay, and I can also change the seed so that we have different sets of leaves. And now just a little recap showing you all the nodes that we have here. You can pause, you can watch them. Let's go on. We have the leaves, but we have to rotate them because they're looking very, very bad right now. This is a serious issue. All the leaves are in one direction. I mean, this can be true if, for example, there is a heavy wind coming from this direction. Probably don't have this wind coming from here. So let's rotate them. But by how much and how? To do that, we need to, of course, use rotate instances node. We rotate instances. Put it here. Bam. And this allows us to rotate in the local space. What does this mean? So, for example, if we're rotating in the world space, this means like that. You see, this is not very good because this is intersecting and doing all this weird stuff here. We don't want that. We want to rotate in the local space. This means each of these leaves is gonna have its own Z direction like that. And then we're gonna rotate and everything is, okay, Z doesn't work at all. So Y is working here, right? So now they're rotating like it should, but we have to have a different value for each of those leaves. Now, how do we do this? We can use the index node. Index is just a number for each point. It's like the name of each point. So you're asking, okay, but we have leaves here. We don't have like, we should have like many points in these leaves, but we cannot rotate all of those with the index. I mean, this is gonna result in some very crappy, noisy, random stuff. But actually this is not the case because these are instances, which means they're actually points. So here is even a node, instances to points, right? This looks like that. They're actually points, they are not real geometry. This is just a leaf instance on those locations. And now we have currently indices of 0, 1, 2, 3, 4, 5, right? So let's use the index as the rotation. But this is obviously very random, and this is because we're using, for example, the number 1 for the rotation on all the axes, but we don't want to rotate on all the axes, only the z-axis. So let's use a combine XYZ, because this allows us to have different controls, different inputs for one vector. And we want to rotate on the Y. This leaf thinks that Y is like the Z or something like, yeah, you understand how this works, right? Maybe you have to use something different here, but if you did everything like I did, like the placement of things, this should work for you very well. This is not the correct way how leaves grow in nature. Actually, they grow using the golden angle. So here, this is the math part, but this is actually very easy. So right now, by how much are we rotating? So this is here is 0, index 0, this here is 1. So by 1 unit, but which kind of a unit? This is a radian, because Blender uses radians as internal rotation units. So when you have like 1 radian, this is 57 something degrees. Doesn't have to be too exact. So this one is rotated by 57 degrees, and seems to be that this is the case here, right? Actually, they have to be rotated by the angle of 137.5 degrees, which is the golden angle. How do we get from 57 137.5? We just multiply this by x, and this equals this thing here. So how do we get the x? Well, this is 2, this is 3, and this is 6. So 3 equals, so x equals, x is like a 3 equals this thing here divided by this thing here. So 3 equals 137.5 and divided by 57 degrees. And this is the x. So we have to multiply the indexes with this expression here to get the right rotation values. So let's use the math node here, put it here, and the multiply, because this is multiplication right here. Let's multiply by 137.5 divided by 57 degrees. And now the plant leaves are looking, I think, a lot more like in nature. Except the one thing that's missing here. All the leaves have exactly the same size. So how do we make them smaller? We can again use the curve parameter. So for that, let's go to the scale here. And let's use this as the scale input. Right, this is working okay. Okay, let's add the probability up here. And does this look like an acceptable plan for you? Not to me. This looks like, you know, this is linear. They are scaling up linearly. But in nature, things usually aren't linear. The leaves should be more like, instead of being like that, they should be more like that. So how do we do this? Well, we just have to use the power function, because this is meaning that if I use something like here, this creates like this curve here, right? And if you want to be like very pretend to know how things work, let's like type in E here, which means like the Euler number or something, and this is yeah, giving us maybe something more natural. I don't know, maybe this doesn't work even like that, but this looks okay, right? Yeah, this looks fine. Now we have to animate. The growth animation needs our work. Right now we don't have any animation here, but we have one slider here that is making it smaller. So let's add a control for this thing here, and we have this one here right now, we can now animate this. But what we need is the scale of the leaves to also get smaller when we do this. And we can do that by altering the scale somehow. So how should we do this? When this is 0, the leaves should have the scale of 0, and when this is 1, they should have the scale of 1. So the common sense tells me that we need to use multiplication, right? So math and multiply, and let's multiply by our number here. Now when we go here and we scale this, the leaves are getting smaller until they disappear, and they're getting bigger up again. Now this looks pretty okay, right? Pretty nice, pretty acceptable, but we are making something great here. So what we need to do is to make sure that when the plant is small, the leaves should be pointing upwards. And when this goes big, they should be like opening up like a flower. So to do that, we need to rotate them somehow. So where is our rotation? So with the X here, we can do something like that. So when the plant is small, the leaves should be like that. And when the plant is getting bigger, the leaves should open up like that. Again, for that, we can use the same value that we use for the trim curve and for the multiplication here. Let's go here and let's track the value to the X here. Okay, this seems not to work very well. Let's see what happens. So when this is at 0, the leaves are not pointing upwards, and when this is at 1, they are pointing downwards. So this has to be inverted. Let's use a map range. Let's map the range. So from the original range of 0 to 1, which is correct, we did have this range, like you see here. We have right 0 to 1, 0 to 1. So we have the original range, and when this is at 0, we want the leaves to be what? Let's test out. We want them to be the new minimum of like that. Actually, it can be even like less, I think. And when this is at 1, the leaves should be pointing how? Like that, I think. I think it looks pretty great, except we don't have a material on this part of the stem here. So to add a material like that, we have to go to the material tab and press here, add a new material, material 001. And let's then go to the geometry nodes here and let's add a material before we add the leaves, because the leaves already have a material. So let's use a set material, put it here, and let's select the material that we need, which is material 001. Now let's go to shading, and as you see we are here, and now we can do so that we are gonna select something green for the stem, like that. Now if you want to make this look a bit better than it is right now, what you need to do is to use a noise texture. A noise texture, and let's use normal coordinates for the noise texture, which means looks something like that. And once this is here, we are just going to use the color of the noise texture as the normal of the principal BSDF. So now this looks something very strong and not essentially very good. But what we can do is to use a mix RGB, and let's mix between the original normal coordinates and the noise texture, so that we can either have a like perfectly smooth thing here or something more like that. So if you use something like 0.6, I think this gives like a better stem for this stem. And let's use also some subsurface scattering, because this is a little faint stem here. So right, this is how this looks. I think it looks pretty okayish. And now you're asking, how can you do so that, you know, it actually deforms and they have this little like branches appearing here and all that stuff? Well, this is something a bit more advanced, so I'm gonna leave this to Patreon because they support me, they're really nice. So see you on Patreon and also next time.